Before going further, guys, give the heading of the question. Question number 12, April 2009, question number 4. After giving this heading, try to read this question minimum 2 times, guys. After giving this heading, try to read this question minimum 2 times, everyone. Now try to see the scenario here, guys. Very simple question. Not that much difficult question. But here we have a few concepts. If you got the concepts, then this question is very, very easy. So now try to see the scenario here. What we have? A box barge of uniform construction. A box barge, we have what? Box shape barge of uniform construction. Whose length is how much? How much length of the barge we have, guys? Tell me. Length is how much, guys? 66 meter long. So length of the barge is what, guys? Really is what? 66 meter and 10 meter wide. So what they are given us, guys? B is what? 10 meter wide. The barge is divided into 3 compartments, guys. See the wordings. Barge is divided into 3 compartments by a 2 transverse watertight bulkhead to form a central compartment. So here how many bulkheads we have, guys? 2 transverse watertight bulkhead. What we have? 2 transverse watertight bulkhead to form a central compartment. So what we are going to do? So what is going to happen? 1 central compartment and 2 equal length end compartments. Guys, see the wordings. So just imagine that this is what our longitudinal view of the barge. So here we will have what? Central compartment. Okay, central compartment and equal length end compartments, guys. What they are saying? 2 equal length end compartments. Getting my point? Try to understand the scenario here. So 2 equal length end compartments. Guys, observe here carefully. Anyone have any doubt till now? So length of the end compartments are same. Okay, length of the end compartment is the same, but central compartment will means all 3 compartment length is not same, guys. Now barge is loaded with a bulk cargo evenly distributed over a full length of the barge, resulting in a permeability of the barge being 60%. So what is permeability, guys? Permeability is what? See, just imagine that. Suppose this is a 1 box, guys. Just imagine that this is a 1 box. In that box, what I am going to do? I am going to put some coal or some, I will say some core, I will say, what we will say? Some coal. Okay. Or iron ore. What I am going to put? Some iron ore. You got the meaning of iron ore? Okay. From means, what we will say? What we can say, guys? From mine, whatever the iron we get it. From the iron mines, whatever the iron we will get, that we will say iron ore. Okay. And then, suppose we will get in such form, guys. Just imagine that. Okay. Just imagine that. So something like that. So, and we are going to put that into what? Okay. Just imagine that, guys. So this is what our iron. Okay. Now try to see the point. So these things. This is, I am highlighting in yellow. This is a space. Okay. Vacant space, guys, here. Okay. And that is nothing but what? Our permeability. So permeability means what, guys? How much percentage of the space is vacant? Means suppose, you got my point. So what is the permeability, guys? Permeability means what? So how much? Okay. So what is that space that is unoccupied? Means actually it is completely occupied. But the few portion, what we can say? Means whenever we have a thing like a coal or iron ore, what will happen guys? Some space will always be there. So here permeability, how much permeability we have? So permeability is what? Percentage of vacant space. So how much permeability we have guys? Everyone tell me. So permeability means what? How much percentage of the space which is not occupied guys. So mu, permeability we denote by mu, and mu is what guys? 60%. 60% means what? For calculation purpose we will take it as a what? 0.6. So the first twist of this question is what? They have given us a permeability. What they have given us guys? Permeability, and barge floats in a river water of density 1008 kg per meter cube. So density of the river water is how much? So 1.008 ton per meter cube. 1.008 ton per meter cube. With an even keel draft. How much even keel draft we have guys? Everyone? Okay, with an even keel draft of what? 5 meter. So what we can say? D is equal to what? How much draft we have? 5 meter. And midship compartment is extending the full width. Now what is the meaning of midship compartment extending the full width? And the depth of the barge? Midship compartment is extending the full width. Now guys, just try to understand. I am going to draw 3-dimensional view so that you will get a proper understanding. So here what I am doing? I am drawing what? 3D model. Okay. So this is what guys, our box barge. And here we will have what? So just imagine that this is what our midship compartment. Got my point guys? This is what our, everyone? Midship compartment. Guys, imagine that. So this is what our midship compartment. So this is what our midship compartment. And what they are saying about midship compartment? Midship compartment extending the full width. So extending the full width means what? This box barge. How much width we have? How much width we have? This is the width of the box barge. This is the width of the box barge guys. So this is the width of the box barge. So our midship compartment is extending for this entire full width. Okay. Okay guys, you got the meaning of extending full width. So extending the full width and the depth. And what is the depth guys? Everyone? This will be the depth. This will be the depth now guys. Okay, we don't know what is the depth, but that is extending for the full depth. Okay, full width and full depth. You got my point. Try to understand the scenario here. So full width, and here we have what guys? Full depth. Okay, so our midship compartment extending the full width and depth of the barge is now bilged. What is happening guys here? Is now bilged, and draft increases to what? Draft increases to what? 5.5. So our new draft will be what guys? What we will say? D final. What is D final we are getting? 5.5 meter. So what is going to happen guys? In this is the midship compartment. In this midship compartment, what is going to happen? This is what our midship compartment. In this midship compartment, what is happening? In this midship compartment, what is happening? Bilging is going to take place, and because of the bilging, water will enter, and then draft is going to increase by what? Everyone tell me. Draft is going to increase by what? 5.5 meter. Getting my point? And our target is what? In A part, we have to determine the length of the midship compartment. So how much length of this midship compartment we will have? So that will be our target. So we have to find out what? We have to find out this length of the midship compartment guys. And we will say length of the midship compartment is what? What we will say? LC. What we will say guys? Length of the midship compartment? LC. Getting my point? Try to understand the scenario. Very simple discussion we are doing guys. Anyone have any doubt in this discussion guys? Tell me. Okay. So our target in A part guys, what we have to find out? Length of the midship compartment. What is our target guys? Length of the what? Length of the midship compartment guys. Our target is what? What we have to find out? Length of the midship compartment. So before going further guys, please everyone add these given things, and roughly if you want you can draw this figure also for your understanding. But in exam you don't need to draw the 3-dimensional drawing guys, because in exam point of view we never like a 3-dimensional drawing. This is for our self understanding. Now try to see the scenario here. What we are going to do? We are going to dot. So now first of all, what will be the displacement of the vessel guys here? First of all, what will be the displacement of the vessel? Volume displace into what? Into density of river water. So okay, length is what? LBD into density. Density of what? River water. So displacement will be equal to what? Length how much? 66 meter. Breadth is how much we have guys? 10 meter. And draft is how much? 5 meter. And density of river water is what? 1.008. So please do the calculation and tell me the displacement of the vessel guys. .4 unit ton. Okay, we are getting a unit is what? 3326.4 tons. So before going further, please everyone add this discussion. No. Throughout displacement will be the same. Just wait for a few minutes. I will explain you. We can't say displacement 1 or 2 here. Here we can't say guys here. For both the scenario, before the bilging and after the bilging, displacement of the vessel is not going to change. And that's the concept of bilging here. We are going to see. Just have some patience guys. I will explain that point to you. So this displacement. No. Here, see, there is a no bilging in the initial scenario. That's why we are considering, but initial displacement and our final displacement is the same. That is what our important assumption in this case, guys. And why we are going to assume this one, I will explain you in few minutes, guys. Now, what is our target in A part, guys? What we have to find out in A part? Our target in A part is what? Determine the length of the midship compartment. What is our target guys? What we have to find out? Determine the length of the what guys? Length of the midship compartment. So our target in A part is what? What we have to find out? Length of the midship compartment. Or I will say what they said. Midship compartment only they said. So we will use that same word. So they are asking us what? Length of what? Midship compartment, and we will give the name to that length of the midship compartment is what? What we will give? The name is what? LC we will give guys. So before going further, please everyone write down the target. Completed guys up to this point? Now try to see the scenario here. So what I am going to do here, I am going to draw the what? Guys observe here. Understanding this drawing is very very important for us, because our entire thing depends on this drawing. So So suppose this is what our box barge. Okay, this is what our box barge. So these are the what our end compartments, guys. Just imagine that. This is what the aft end compartment. So 8 compartments are of what here? Equal length. Guys, end compartments are of what here? Equal length. Suppose here we have what? What I am going to do? Suppose this is what our initial water line. This is what our initial water line, that is even keel. And final also here, even keel situation, guys, here. So this is what our initial water line. And that is what we will say? WL. Then we will have what, guys? The next thing. So new water line, our draft is going to increase. And new water line will be what? What we will say? W1, L1. So initial draft is how much, guys? Tell me. Initial draft is how much, guys? 5 meter. So from here to here, this will be what? Everyone, initial draft 5 meter. And then by draft, it will increase by how much amount? 0.55. Sorry, 0.5. So new draft will be what? So 5.5 meter. So this distance will be what, guys? 0.5 meter. Anyone have any doubt in this discussion, guys? Tell me up to this point. Let me know if you have any doubt. Okay, good. So we have what? Now what is going to happen, guys? See how much permeability we have. Permeability 60%, 0.6. Guys, remember my point. So just imagine that permeability means what? How much space we have vacant, guys. Permeability means what? How much space that is unoccupied. How much space that is not occupied, guys. That is meant by permeability. Just listen my words carefully. So here, then how much percentage occupied? 40% will be occupied, guys. So, and just what we will do, guys, everyone. So this portion, just imagine that. I am showing with the help of this one, this hatching. Guys, observe, understanding this concept is very, very important. If you got the concept, then things will be very, very easy for you, guys. So if you are feeling sleepy, guys, take a long breath. Take a long breath, guys, always. If you are feeling sleepy. Or keep a cup of coffee, cup of tea. Okay. Okay, good, guys. So now, guys, try to see the scenario here. So this portion, that portion I am showing, but before that, 1 minute, guys. Before showing that portion. So what we assume? Length of the midship compartment, what we assume, guys? Length of the midship compartment, what we assume? How much length of the midship compartment we have assumed, guys? Tell me. Okay, length of the midship compartment we have assumed LC. For that purpose, to show the LC, I am going to draw one dotted line from here. Another dotted line from here, guys, observe. And I am going to make it as a what? LC here. Don't write anything, just listen my words carefully here. Don't write anything now. Let me first of all complete the things. So we don't know this length of the midship compartment. So LC, guys. Now then, next. What we are assuming, guys? This portion. What we are assuming for a sec. Just for a sec, guys. Suppose this, basically, this is completely occupied. But out of that, few space will remain. So for that purpose, guys, what we will do? Just we will assume. Imaginarily what we did. Actually, this will be not like this, guys. Cargo, what will be the, how will be the cargo, guys? Basically, that cargo will be something like this. Just imagine that. Cargo will be what? How will be the cargo? Something like this. Okay, something like this. And we will have what? Some vacant space in between that. That will be the scenario here. But what we will do, guys, to make the thing simple, what we did, we just shifted cargo on one side. Means we will assume what we are going to do. We are going to shift what? Cargo on what, guys? Just to make the calculation simple, to get the things to understand what we are doing. We are shifting the cargo on what, guys? Okay, not midship. Midship here we will have somewhere here. Okay. Okay. So here, okay. So here we will have what? Somewhere here we will have midship, but we don't need here midship. So guys, see the scenario. So this will be what guys, everyone, means actually, suppose this is, just imagine that this is what our midship compartment. This is what our midship compartment. Just imagine that. In that we have a cargo something like this. But to make the thing simple, what we did here, these things are what? These things are what? Vacant space, that space. So to make the thing simple for the calculation purpose, what we did, we assume, what we are assuming, we are putting whatever the space which is occupied by the cargo, we are shifting on one side, guys. So that means actually vacant space is like this, guys. This is what our 60% is vacant, unoccupied, not occupied, and 40% will be occupied. Permeability means what? How much percentage of this not occupied, guys. So that I have not drawn here, guys, everyone. So this portion that I have shown here, guys, that will be what? This portion that I have shown here, 40%. Okay, guys, getting my point? So this is what this portion denote what? Tell me, guys, what this portion will denote? Okay, this is what a cargo, guys. Try to understand my point. This portion denote what? Everyone tell me. This portion denote what, guys? Cargo. Okay. So now, guys, observe the scenario here further, what we have to do and how we are going to approach. So suppose this entire length is what we are assuming. Entire length is LC. Okay. Then the next thing. Next point is quite interesting, guys. Try to understand the next point, what your teacher want to see the next point. Okay. Try to see the next point, guys. So what will be the next point here? 1 minute. So, can anyone help me with how much will be this length? Can anyone 0.6 times LC, correct? Means what we can say, mu LC. Can we say, guys, mu LC, this length? Everyone? Okay, good. Then, getting my point? Mu LC. And then this remaining will be what? This remaining will be what, guys? Everyone tell me. So mu LC, sorry, LC minus mu LC. So this remaining will be what, guys? Everyone? LC minus mu LC, and that will be equal to what? 1 minus mu LC. Can we say? This length, guys, everyone. Can we say? This length, LC minus mu LC, and that will become what? We can take out LC common, and then here we will remain 1 minus mu LC, guys. Can we take? So this length will become what? The length in which we have a cargo portion. Means what we assume, guys, instead of showing this blank space everywhere, means throughout, just what we did, the portion means where we will have only cargo, we just shifted that one side, and the blank portion which is not occupied, we have shifted on other side to make the thing simple, guys. Getting my point? Try to understand the scenario here. Now what will happen, guys, here? So here bilging, because of the bilging, what is going to happen? Water is going to enter. Because of the bilging, what is going to happen, guys? Tell me. Water enters into this one. But in which portion water is going to enter? In the cargo portion or the portion which is unoccupied? The portion which is not occupied. And in which portion it is, guys, bilging is going to take place? In this midship compartment. See, this is what our midship compartment, guys. This is what our midship compartment. This is what our midship compartment. And then out of that, 40% is occupied and 60% is what, guys? This 60% is what? This 60%. Unoccupied, not occupied, guys. Okay, so in which portion, where will water will enter, guys? The portion which is not occupied, guys. The portion which is not occupied, in that portion water is going to enter. So where water is going to enter? So here I am showing the water. Observe here, guys, carefully. So in this portion, what is happening? Water is entering, guys. What is happening, guys, in this portion? Tell me, everyone. In this portion, what is happening? Water is entering. Water is entering, guys. Take a long breath, everyone. So water is entering. So now try to understand the scenario here. So now here assumption is what, guys? Here, this part in which water is going to enter, this part. Guys, everyone. This part. 1 minute. Let me use a different highlighter. This part where water is going to enter, this part is not a part of the ship, guys. What we are assuming? This portion, this part will become what? Before. Okay, after bilging, what we are going to assume, guys? Remember my point. After bilging, what we are going to assume? This portion will not become will become a part of a sea, not a part of a ship, guys. Not a part of this our barge. Okay, this portion will become what? Everyone tell me. This portion will become what, guys? Tell me, everyone. Part of the sea. This portion will become part of the sea. Now, guys, see. Who is floating the vessel? Who is floating? Who is responsible for the floating of the vessel, guys? Tell me. Who is responsible for the floating of the vessel? Buoyancy. Correct, guys. Very good. Who is responsible for the floating of the vessel? Everyone? Buoyancy, guys. Now the next thing is what? Guys, see. Who is responsible for the floating of the ship? Buoyancy is the responsible for the floating of the ship. Now, see. Now, earlier, guys, this portion, guys, this portion that I am showing, which is not currently part of the ship after the bilging, this portion is also responsible for the buoyancy. Guys, what is meant by buoyancy force? Buoyancy, who is, see, whatever the water we are going to displace, that water displace is nothing but a water buoyancy. But earlier, this portion was displacing the water, guys. Before the bilging, this portion, what this portion was doing? What this portion of the ship is doing, guys? Everyone tell me. This portion that I am showing, I have shown in this hatching, guys. This portion that, guys, everyone, this portion is what? Responsible for the hatching. Means for it, responsible for the buoyancy. Means basically not only this portion, this entire portion is responsible, guys. Earlier, before the bilging, who is responsible for the buoyancy, guys? Everyone. This entire portion. Just imagine that. This entire portion is responsible for the buoyancy. Okay. But now, in the second scenario, guys, which part is responsible for the buoyancy, guys? Tell me. This portion that I am showing in green. This portion is responsible for the buoyancy. Now, guys, getting my point. Which portion is responsible for the buoyancy now? See, guys, what is meant by buoyancy? Buoyancy means what? Weight of water displaced, guys. Or mass of water displaced. Guys, what is meant by buoyancy? Buoyancy means what? Everyone? Basically, buoyancy means what? Buoyancy force means what? Weight of water displaced. Weight of water displaced. Initially, that rate hatching that I have shown before the bilging, that rate hatching is responsible for the buoyancy. Now, after the bilging, who is responsible for the buoyancy, guys? Because this part now, this one, guys, everyone. Observe. This part will be what? Tell me. This part will be what, guys? Tell me. This part, is it a sea, part of the sea? part of the water, guys, part of the river water. In this case, we have a river water. So part of the river, we can say part of the river in this case. So now the remaining portion, this one that I have shown in the green hatching, guys, this green hatching is responsible for the buoyancy. So guys, everyone try to understand my point here. So what we can say, this portion, guys, now observe. I am showing now here this portion which is responsible for the buoyancy. This portion I have shown in the what, guys, everyone, this, okay, this portion now it is not contributing anything in the buoyancy, guys. This portion earlier it is contributing to the buoyancy. Now is it contributing to the buoyancy? Tell me, is it contributing after the bilging? Tell me, guys, everyone. It is what, guys, tell me. Okay, it is what, a part of the sea, guys. It is a part of the sea. So now see, what is our assumption, guys, here? Our assumption is what? Whatever the displacement of the vessel before the bilging, after the bilging, displacement of the vessel, we are going to remain same. See, what is we are assuming? So whatever the displacement of the vessel before the bilging, after the bilging will also displacement remain same, guys. That is what our assumption here. So now, guys, everyone, what is happening here? This portion. So now we see displacement, whatever the mass will be equal to buoyancy, displacement will be equal to buoyancy. So if you want to maintain a displacement, guys, so whatever the loss we are getting from the buoyancy, whatever the loss, this is basically we are losing the buoyancy in this region. In this region, what is happening, guys? That I have highlighted in yellow. In this region, what is happening? Tell me, guys. In this region, what is happening? Loss in buoyancy. In this region, what is happening, guys? Loss in buoyancy that I have highlighted in yellow. So there is loss in buoyancy. But if we are maintaining a constant displacement, wherever we are losing the buoyancy, there should be some gain in buoyancy, guys. Then and only we will have a same displacement for a given displacement. So what will happen, guys? So what will happen? This portion, guys, observe here. This portion, guys, everyone, observe here. This portion that currently I am showing, this portion will become what, guys? Tell me. This portion that currently I am showing, what this will become? Whatever the loss buoyancy will going to happen, same will be in this pink gain in buoyancy. Then and only vessel will be have a same displacement, na, guys. That is what our assumption na here. What we are going to assume? See here, we are assuming that the portion that is entering into the sea, that this water is what part of the river will become. So here, this portion that I have highlighted in pink, yellow, now this portion is losing the buoyancy. Now this portion is not contributing anything to the buoyancy. But now, which portion is extra? That buoyancy, this portion that is lost in buoyancy, who is going to gain that buoyancy, guys? To compensate that one, to compensate that portion, this portion that I have highlighted in pink, this portion will contribute into what, guys? Everyone tell me. Contribute to the that loss. Means, guys, see, contributing to the loss. Okay. Means this is what this portion that I have highlighted in yellow, that is a loss in the buoyancy. This portion after the bilging is not contributing to the buoyancy. But now, after the bilging, guys, this portion, earlier it was not contributing to the buoyancy, but now this portion is now contributing to the buoyancy. So what will become, guys, everyone? Whatever the loss we are happening due to buoyancy, that must be equal to what? This portion that I have highlighted in the, that will be the what, guys? Everyone, gain in the buoyancy. Getting my point? Try to see the scenario here. Okay. Anyone have any doubt in this discussion? Tell me. Guys, tell me, anyone have any doubt in this discussion? Ross and Paul, where are you guys? You are not speaking with me. Okay. Paul, you are not today at your home, na? You are at South Shield, na? Okay, good. Okay, then you can speak. So, guys, try to see the scenario here. Anyone have any doubt till now? Tell me. Okay, good. So now, I'm going to make it, the drawing will become little bit complicated. To make the thing simple, I'm just erasing few points here because I have that option to erase the few things here. And whatever things we require, only that things I'm going to show here, guys. So just 1 minute, have some patience. I'm erasing few things here. So first of all, I'm showing our initial water line. So this will be what our initial water line, guys. Okay, then this is the our transverse bulkhead. Okay, then in this portion, this is what our, tell me guys, this is what our cargo. Okay, this entire one will be cargo. Now here we have what, this portion. This portion will be what, guys, I have shown here. Okay, so this is what our, this portion, guys. Everyone tell me what this portion denote. Okay, not this portion, guys, everyone. So that is not a lost. I will show that. But this is what our now part of the C. And what will be the, guys, over here, observe here. This portion, guys, everyone. This portion. This will be what, guys? Okay. Buoyancy lost, guys, everyone. Loss in buoyancy. This portion denote, guys, can we say? This portion will be what, guys, everyone? Loss in buoyancy or buoyancy loss. Loss in buoyancy. And then that I am marking in the red. Earlier this portion is not contributing to the buoyancy. This portion will be what, guys, everyone? Okay, this portion is now what it is doing, guys, that I am marked in the red. Okay, so this is what, guys, everyone, this portion will denote what? Gain in buoyancy, guys, everyone. This portion will denote what, guys, everyone? This portion denote what? That I have marked in red, guys, huh? That's why I am using different color pen, so this will be what, our gain in buoyancy, guys, huh? You got my point, everyone? Okay, then and only our, that assumption is what, guys, here what we have assumed. Before the bilging and after the bilging, displacement of the vessel is not changing. And if you want to maintain the constant displacement, so whatever the loss in buoyancy, guys, this portion is now not now contributing into the buoyancy. And this portion is now contributing to the buoyancy, that red one, guys. This green one is not contributing to the buoyancy after the bilging. But after the bilging, the red one is contributing to the buoyancy. Extra contributing to the buoyancy. So whatever this one, loss in buoyancy, must be equal to what, guys, everyone? We can say gain in buoyancy. Okay. Okay, so what we will say, everyone? So for equilibrium, guys, everyone, always try to use a big words, guys, huh? So our target is what? Impress the examiner. Okay, so like suppose you are newly married, guys, and our target is what? To impress our partner. So same thing, what you have to do, guys, our target is what? To impress our examiner, guys, huh? So for equilibrium, what will going to happen, guys, for equilibrium? Okay, okay. So volume loss in buoyancy or loss in buoyancy. Loss in buoyancy will be equal to what, guys? Loss in buoyancy. Buoyancy will be equal to what, guys, everyone? Gain in buoyancy, can we say? And in which portion? Whatever the volume, guys, huh? See, here, basically, buoyancy means what? Water displaced, guys. Mass of water displaced. But here, density in this portion and density in this portion of the water is the same. So what we can say? What we will say? We will say instead of that, we will say volume loss. So what? So volume loss in buoyancy will be what? Loss in buoyancy. Length, mu LC. into what? Breadth. And how much initial draft we have, guys, everyone? How much up to this portion? 5 meter. Okay. Okay, good. Then gain in buoyancy, guys, everyone. This red one. In that one, guys, everyone, how much depth of this portion? First of all, how much will be the length of this portion, guys, where we are gaining the buoyancy? 60. See, total length of this one, guys, everyone, 66. 66 minus mu LC, length will be what? That portion. 66 minus mu LC. Okay, see, this portion is what, guys, everyone, tell me? This portion is what, everyone? This portion, mu LC, this portion is what, guys, everyone? Mu LC. So, the remaining portion length will be what? 66 minus mu LC, guys. Now tell me, what will be the entire length of this barge? What is the entire length of the barge? Sir, tell me. What is the entire length of the barge? From here to here, guys. 66 meter. Now, which portion is not contributing into the buoyancy? Okay, this portion is not contributing into the buoyancy, na? Remaining portion is contributing to the buoyancy. So, this mu LC is not contributing to the buoyancy. Mu LC is not contributing into the buoyancy. So, what will be this length? Tell me. The remaining portion length will be how much total? 66 minus mu LC. 66 minus mu LC. Now, guys, listen my words carefully every here. Huh? Understanding this concept is very, very important. So, 66 minus mu LC. Here, entire breadth. Then, how much portion is responsible? How much depth of the gain in buoyancy, guys, everyone? 0.5. 0.5. Okay. And what are the things we can cancel? Breadth we can cancel, guys, everyone. So, mu is how much? 0.6 into LC into what? 5. 66 multiplied by 0.5. 33. Mu is what? 0.6 multiplied by 0.5 LC. Getting my point? Try to understand. 0.6 multiplied by 5. 0.6 multiplied by 5, guys. 3 LC. 5. So 33. Okay. So minus what we will say, guys, everyone. So here 5, so it will become 0.03 LC. Guys, observe the scenario here. Okay, guys, any mistake from my side? Check it. So guys, observe here. So we will shift this one, this side, 3 LC. So 0. Yes, 0. Okay, sorry, my mistake. This must be what? 0.3 LC. Okay. So here 0.3 LC equal to 33. So 3.3 LC. 3.3 LC into 33. So LC will become what, guys? Tell me, everyone. 10 meter. So in this way, we got a what? Length of the midship compartment, guys. And that is what our target. Got it now, my guys? My point, everyone? Just you have to understand. See, this green one, the green hatching denoting what? Loss in buoyancy. Whatever the loss in buoyancy, that red hatching that I have shown, this red hatching denote what? Gain in buoyancy. To maintain the equilibrium of the vessel, guys, whatever the loss in buoyancy should be equal to what, guys, everyone? Gain in buoyancy. Just this is the concept, guys. And here what we are assuming? We are shifting the cargo on one side to make the calculation simple, guys. But actually cargo will be like this, guys. But to make the thing simple, what we are doing? We are just making this entire portion is occupied by the cargo, and this 60% portion is what, guys, everyone? This 60% portion is what, guys, everyone? Tell me. Is unoccupied, not occupied. Okay, that is what here assumption. Here few assumptions here we have to make the thing simple, guys. So before going further, please everyone draw this figure first of all. And then after this drawing, write down this discussion, guys, everyone. Now guys, try to see the scenario here, what we have to do and how we are going to approach, guys. In B part, for the final condition. Final condition means what? After the bilging, guys. Final condition means what? After bilging. Draw the curves of mass and buoyancy distribution, guys. What we have to draw? Draw the curves of mass and buoyancy distribution. That is what our target in B's first part. So what is our target in B's first part? We have to draw what? Curves of what? Mass and what, guys? Mass and what, guys? Everyone? Mass and buoyancy distribution. Try to understand my point here. So in B's first part, our target is what? We have to draw the curves of what? Mass and buoyancy distribution. And for that purpose, we need a buoyancy, guys. First of all, buoyancy in what? Everyone? Buoyancy in compartment 1. Guys, see. Buoyancy in compartment. So here we will give, guys, everyone. We will give the names to the compartment here, guys, everyone. So this is what a compartment 1. Then this will be compartment 2. And this will be what? Compartment 3. Just add these three things here on the drawing. That's why I always tell you guys, always try to draw the bigger drawings. Means suppose we have a Mumbai, guys. Suppose in India, suppose this is a map of a general map of India, guys. Suppose we have a Mumbai. Okay, a new city is developed in 1990. It is not up to the European city, guys. It is only average city, not up to the standard of European city, but it is better than the Mumbai. So in that is new Mumbai is developed in the 1990. Little bit planned, not up to the European standard, guys. So there means as per, like, suppose if you visit any European country, what there will you will come to know that means always something for the future, means always means whatever things we needed in future, you can easily accommodate there. Same thing way, guys, always try to draw the bigger drawing so that in the future if you add something in that drawing, guys, then you can easily accommodate that things in the drawing, guys. Getting my point? Try to understand my point here, what I want to say. So now try to see the scenario here further. So guys, observe here. Now buoyancy. Here, buoyancy, length of the compartment 1. How much will be the length of the compartment 1, guys? Can anyone help me? How much will be the length of the compartment 1? This length will be how much, guys? How much will be this? How much that length? How much this length of the compartment 1, guys? Tell me. So then tell me how much that one? 28, guys. So length of the compartment 1, 28 meter. Length of the compartment 3 is how much coming, guys? Okay, so that is 28 meter. Okay, don't add anything. Okay, so this is what 28 meter. Don't add anything in this drawing, guys, now, for now, because we will draw another drawing afterward. But for this one, length of this compartment 1 and compartment 3 is what? 28 meter, 28 meter. So buoyancy, okay, buoyancy in compartment 1, guys, see the wording. Buoyancy. Buoyancy in end compartments, guys. How much buoyancy in each of the end compartments? Buoyancy in what? Buoyancy in what? Each of the end compartments. Buoyancy in what? Each of the end compartments will be what, guys, everyone? Can we say buoyancy in each of the end compartment? So buoyancy will be what? Volume displaced. Whatever the mass of the water displaced, that will be our buoyancy. So in end compartments, mass of water displaced will be what? Length final draft into breadth, guys. Length of the end compartment 28 meter. Breadth and final draft, guys, into density of river water. Guys, got this point, everyone? Buoyancy in each of the end compartment, guys. Everyone got this point? Okay, means buoyancy in each of the end compartments, guys. So what are the end compartments here we have? Compartment 1, and what? Compartment 3. So length of each compartment is 28 meter. Draft final situation 5.5 meter and breadth is a B. So buoyancy means what? Weight of water displaced or mass of water displaced, guys. And then mass of water displaced will be equal to what? Volume of water displaced into density. Anyone have any doubt in this one, guys? See, length of the 28, volume of water displaced into what, guys? Density, guys. So this will be what, everyone? Volume of water. So 28 into breadth. Breadth is how much, guys, everyone? Tell me how much value of breadth we have? 10 meter. Final draft 5.5 and density of river water 1.008. So buoyancy in each of the end compartment, guys. How much buoyancy in each of the end compartment? Tell me. How much, guys? 1552 point, what, guys? 32 ton. Okay, this is buoyancy in each of the end compartment. Buoyancy in what, guys? Buoyancy in midship compartment, suppose. So buoyancy in midship compartment. Guys, see, who is responsible for the buoyancy in midship compartment? See, who is responsible for the buoyancy? This portion is not responsible, guys. This portion is not responsible for the buoyancy. Okay, guys. So this cargo portion, so that will be what? That portion length is what? 1 minus mu LC. 1 minus mu LC, that portion length. Length of this portion is what, guys? Tell me. What is the length of this portion? 1 minus mu LC into breadth into D final into density of river water, guys. Everyone? Okay, good. So 1 minus 0.6 LC, 10 meter we got it, into breadth is 10 meter, guys, into draft final 5.5 and density of river water 1.008. So please do the calculation, guys, and tell me the buoyancy in midship compartment. Two to 1 point, what, guys? 76 unit. What will be the unit, guys? Tell me. Ton. Okay. So before going further, how much further? So guys, before going further, please everyone add this discussion in your notes. So now buoyancy per meter, guys. See this one. Buoyancy per meter in end compartments. What will be the buoyancy per meter in end compartments, guys, everyone? So how much buoyancy we got it, everyone? 1552. 1552.32 and length of each compartment is what? 28 meter. So do the calculation and buoyancy per meter in end compartments will be what, guys? Everyone. $55.44 unit tons per meter, guys. And buoyancy in midship compartment, buoyancy per meter in what, guys? Everyone, in midship compartment. Okay, 221.76 divided by what? 10, guys? That will act throughout then. So 22 point what? 176 ton per meter. Okay. So before going further, please add this discussion. And here mass is acting uniformly, guys. Here mass is acting uniformly. Mass per meter, guys. So how much total mass we have, guys? Tell me how much total mass we have. Total mass we have 3326.4, correct? 3326.4. So mass per meter 3326.4 divided by what? 66. So please do the calculation, guys. 3326.4 divided by 66. How much it will become, guys? 50.4 ton per meter. Getting my point? Try to understand the scenario here. Okay. So our target is what? We have to draw the curve of what? Buoyancy and mass, guys. Our target is what? Tell me what we have to draw. Draw the curves of what? Mass and buoyancy distribution. So simple, guys. You can draw it on the graph. For now, I am drawing just simply. You can draw it on the graph, guys. But for now, I am drawing here only. You can draw it on the graph also, guys. Okay. But for now, I am just drawing here. But you have to draw it on the graph in exam. So here we have what? Just imagine that. Suppose this is a 10, 20, 30, 40. So 50, 60, 70. Okay. Guys, getting my point? Try to understand the scenario here. Just let me little bit zoom it so that 10, 20, 30, 40, 50, 60, 70. How much total length we have, guys? Tell me. Total length is what? 66. So total length is how much we have? 66, guys. Everyone. So see. Guys, here I am drawing roughly here. Just you can take a proper scale and as per that one you can draw. Okay. So just here for me 10, 20, 30, 40, 50, 60 and 70. So just what I am doing, guys, everyone. Up to this one. Guys, end compartments. 28, guys. So 28 means what? That will be how much buoyancy we are getting? In end compartments, how much buoyancy we are getting? 55.44. So roughly, I am drawing what, guys? Everyone? Up to 28. Guys, observe here. I will erase these things so that you will not get confused. Okay. So up to 28, what I am doing, guys? 55.4. Okay. So this will be what? 55.4. 50 point. How much, guys? Exactly. 55.44, na? Up to 28. Then next one. Next will be what, guys, everyone? For the next 10 meter. how much guys for the next 10 meter per buoyancy per meter? So here if you draw one dotted line from here guys, everyone, 1 minute. If you draw the dotted line from here, this will be what, our 28, 0 to 28. Then next one, 28 to what guys, everyone? So if you draw the dotted line from here, so this will be what, our 38. And then at the end, so how much, the next thing is how much guys we have? 22.176. 22.176. Okay. And then again 55.44. Okay. Again we have what guys, everyone? So see the scenario here guys. So this will be what guys, everyone, at the end? 66. Okay, getting my point? So again 55.44. Okay, so this is the what? This curve will denote what guys, everyone? What this curve will denote? Buoyancy curve. Okay, and at the end mass curve will be what? This is what? 50.4. So mass must be negative side. So what we can say? Minus 50, and it is the same mass curve. Mass will be same here throughout. Minus 50.4. Okay guys, getting my point? Try to understand the scenario here. Very simple discussion we are doing guys. Check it if you have any doubt. So here on this, so this is what our distance is. So buoyancy per meter, and here what? Mass per meter, and both will be in what? Ton per meter guys. So that is what our this graph. You can draw, take a proper scale, and as per that you can draw this one on the graph guys. Here I am not going to suggest a scale. As per your convenience, you can take a scale and you can draw it on the graph guys. In exam you have to compulsory draw on the graph. For now you have to draw it on the sketch. For now you have to draw it on the sketch, on the notebook for now. But after the class guys, draw it on the, after the class draw it on the graph book guys. So before going further, please everyone, have you added mass per meter guys? Have you added mass per meter? Okay, add that one also, mass per. Okay, after the buoyancy per meter in midship compartment. Okay, after that add mass per meter, and then write down this discussion guys. Okay, completed guys up to this point? Okay, good. Now the next thing is what guys? The next interesting task is what guys? Our with second part, what they are asking us, determine the longitudinal still water bending moment at midship. What we have to find out guys in the B part? Longitudinal still water bending moment at midship, stating whether it is hogging or sagging guys. So our target in B part is, with second part, what we have to find out guys? Bending moment at a what? Everyone tell me. What we have to find out guys? Tell me. In bending moment at what guys? Okay, bending moment at midship, and whether it is hogging or sagging. And for that purpose, what we are going to do? We are going to draw what? Just a basic drawing, so that we will have a proper understanding. Observe here. Now this is what our midship guys here, everyone. So this is what our midship. Here, suppose guys see, here buoyancy is how much we got it. Here buoyancy, how much we got it in this one. How much buoyancy we got it? Tell me. In the end compartment, how much buoyancy we got it? In end compartments, we got it how much guys? In end compartments, 1552.32. In end compartment, how much buoyancy we got it guys? 1552.32. So this much buoyancy we got it, 1552.32 unit ton guys. So in compartments we are getting a this much buoyancy. Yeah? So in midship compartment, how much buoyancy we got it? In midship compartment, how much buoyancy we got it guys? 221.76. 221 point what guys everyone? 221.76 guys. Huh? So in midship compartment, this much buoyancy we got it. Now the next thing here, I am mentioning the lengths also here for their simplicity. And for that purpose, I am drawing one dotted vertical line. Here also one vertical line. Here also one vertical line. 1 minute guys, and don't write anything because I am going to explain a lot of things here. So now then, from here to here, how much will be this distance guys? Tell me. 28 meter. Okay. Then this will be what guys? Everyone tell me. 10 meter. And then this will be how much guys? 28 meter. Good. Then next thing guys. Here. See. This buoyancy. See this buoyancy where it will act guys? So from here, exactly at the center. So, guys, I am drawing one dotted line from here. Just observe this dotted line. Guys, observe. 1 minute, let me use a proper straight line so that you will get a proper understanding. Now guys, can you help me with this distance? Guys, can you help me with this distance? How much will be this distance guys? Can anyone help me with this distance? 5 plus 14? 19 meter guys. What will be this distance will become? 19 meter. Then I am drawing one dotted line from here. Okay. So, tell me this distance will be how much guys? This distance will be what guys? Everyone tell me. This distance will become what? 2.5 meter. Huh? So, we need a bending moment at midship. And here a cargo is included in the mass only guys. Huh? Here cargo and hull mass both are included together. So, first of all we will see the buoyancy effect. So we discussed in our last lecture guys how to get a bending moment. Either we have to see the left hand side forces or we have to see the what guys? Everyone? All the forces. Okay. So we have to see the what guys here? Everyone? Either we have to see left hand side forces or what guys? Everyone? Or the right hand side forces. So see. On left hand side just we are considering suppose left hand side. So left hand side we have what? This buoyancy force in this compartment, and for this compartment buoyancy force is what? 1552.32. This buoyancy force acting in this compartment. But this buoyancy force where it will act guys? It will act here. Center of that compartment, and from the midship how much distance of that point? 19. So multiplied by 19. Then here guys in midship compartment how much buoyancy force we have? 1.32. How much buoyancy force we have guys everyone? 221.32 na guys, check it. In midship compartment, how much we have buoyancy force guys? 1 minute guys. 221.76 guys, so my mistake. 221.76, so that is what a buoyancy in the what? In the midship compartment, 221.76, so entire buoyancy. But we have to see only half effect, only on other side. So other side of effect will be what? 221.76 divided by 2 and multiplied by what? 2.5. Now the mass, that mass that they have given us guys, everyone, that mass we calculated guys. This is acting uniformly throughout. This is acting uniformly throughout. But we have to see the mass of the only half portion. We have to see the mass of only half portion, because while calculating bending moment guys, while calculating the bending moment, we need only half side, either left or right side. So, and mass effect is what? Minus, how much mass we have guys, tell me? 3326.4 divided by 2, and it is acting on the what? Total length is 66. So 33 by 2 guys, everyone. So this is what, suppose this is what a total hour. So this is what, just imagine that this is what a total length of the barge. Now then it will going to act what guys, everyone? It is going to act only for what? While considering, we have to see only this half portion. And where that will act guys, everyone? Where that mass is going to act? Center of the half portion while calculating. And we have to see this distance there. And then we have to see this distance. Guys, everyone getting my point? And this distance will be what? 33 by 2. Okay, good. So do the calculation guys and tell me the value of bending moment at midship. Because this is the buoyancy force of this entire compartment. Now see this one. If you are considering half na, then that buoyancy of the entire ship na. This is the buoyancy in each of the end compartments na. Okay, you are getting a point. This is the buoyancy of what? This is 1 minute. This is what? For the buoyancy of end compartment. Guys, do the calculation, everyone. How much guys we are getting? 2328.48 unit ton meter. And as we are getting a positive, means what guys, everyone tell me? It is what? It is what, a sagging. So guys, please complete this discussion. 1 minute. Before that, start writing, try to draw this figure properly. And try to understand the meaning of each and every word guys. If you have any doubt, feel free to ask me. Guys, completed? Drawing completed? Now start writing down this remaining one guys.